In the previous video, at the end of the video, we actually talked about the 4 steps required in order to find your objective. Our objective is to actually find this one, ELX, longitudinal x. So in other words, it's Young modulus in the longitudinal x direction. Okay, also the shear modulus xy. Alright, so therefore, it's talking about the xy direction. Okay, this is the x and this is the y direction. So you want to translate all these laminates, alright, 4 lamina, alright, or these 4 plies, alright, into the xy direction, alright, in order to get the overall Young modulus and the shear modulus of the whole full plate. Alright, so this thing over here is for the Young modulus and shear modulus of all the 4 plies act together. Alright, when they add up together, the Young modulus and the shear modulus for this one is for this 4 plies. Hopefully this is pretty clear. Okay, so therefore we say that the first step we're gonna do is to find our QIJ. Alright, and then we can find the transform stiffness matrix and then the axial stiffness matrix. So in this video we'll cover only QIJ, as there is a lot of things that is also within this QIJ. Alright, so we say that the reduced stiffness matrix QIJ, alright, comprises of all these things. Alright, where this Q11, everything, if you remember, are all this. And the first thing you see is like, wow, so many formula. But you think about it, the denominator are all the same. Alright, the denominator are all the same. So the only numerator that they are talking about is for Q11, Young modulus is E1. Very straightforward. For Q22, Young modulus is E2. That's all. Except for the Q12, maybe you need to talk about the viscous, the Poisson ratio, and the E2, which is the Young modulus in 2 direction. That's all. Okay. Or the last one, Q33, is the shear modulus in the 1-2 direction. Finish. Alright. So this is, don't confuse yourself with the shear modulus G12 with our GXY. Alright, our GXY is this one. Alright, XY is in the XY direction. 1-2 is in the 1-2 direction. So definitely different, right? So therefore be careful when they talk about the shear modulus in the lamina in the X direction. So they want in the X direction, not in the 1-2 direction. But nonetheless, if other question ask for it, then you will propose this G12, that's all. It depends. Okay, so in order to calculate E1, alright, you use these formulas, and the rest you can just check it out. Alright, it's pretty straightforward, and also pretty straightforward to troublesome you need to memorize. Anyway, however, you may wonder, where are the properties? I need all this so where can I get? In the question, they actually provided you all this stuff. However, the purpose of me putting it at this moment right now is that I want to highlight the importance that you may also need to refer to the table, or a certain table where that talks about the certain modulus of the fiber, Poisson ratio of the fiber, and things like that, and you need to pluck it out from there. Alright, so the table will have a table may look something like this, alright, showing all the properties, but it's not this. Alright, it's not this. However, I just want to say that they may give you this type of thing, and then give you the materials, and then you need to choose your stuff, or you need to know what values to plug in and things like that. Okay, so in this case we have been given all this, so I'll just simply copy this and bring it to the page that is what is needed for us for calculation. Okay, so give me a while. Okay, so the properties are being rearranged, so it's easier for you to see. And if you think about it or see this one, I believe that inside the exam question they didn't give you this. Alright, so therefore you need to assume your stuff. So sometimes when they don't give you certain stuff, what you need to do is to assume a very logical answer to that. Okay, and therefore in this case, alright, let's solve for Q11. Okay, so Q11 requires you to find your E1, alright, which is E1 over here. So this EF is the Young modulus of your fiber, or Young modulus of fiber, 140. Alright, this is the volume fraction of your fiber, which is 75%. In other words, you have to convert to 0.75. Alright, this is for your matrix, Young modulus of your matrix or resin, 5 GPa. And then the VM, your volume fraction of your matrix. Alright, there is no volume fraction of a matrix, but if you remember, the VF plus VM should be equals to 1. So you know your VF is 0.75. So what you have is Vm is equals to 1 minus 0.75, which is 0.25. So your Vm is a 0.25. Okay, so my handwriting is a bit messy, so you give me a while. And therefore, let's just calculate E1. Okay, so we have all the values. I'll just sub it in. And please take note that you have to write the units because it's easier for you to so-called reference, because sometimes it may be megapascal and then you need to convert. So when doing calculation, it's very important to do this. And also during calculation, please write down the general formula. You got the marks, or they'll give you marks. So once I calculate for this answer, E1, what I have is 106.25 GPa. Okay, so besides calculating for where's my pen? E1. Alright, so besides calculating for E1, I need to calculate for this Poisson ratio, V12, alright, and this V21. Same thing, I'll just need to so-called sub in, because these are all the things is the same. Volume fraction, this is your Poisson ratio of your fiber, this is your volume fraction of your fiber. Okay, so your Poisson ratio is for your fiber is, you assume it to be 0.3, and then for your matrix you assume it as 0.37. Okay, and then you just sub it in also. Okay, so what I have, I don't go through the math, but I'll just show you the answer. It's 0.3175. Alright, it's a ratio, so there's no units. Alright, just numbers. Okay, and then next over here, and this one, please remember when you calculate certain stuff. So for example, if I were to calculate this, alright, remember is a the volume fraction divided by the Young modulus. Okay, so as you can see, this is also volume fraction divided by Young modulus. This is volume fraction divided by Poisson ratio. This is for E2. Alright, you need to find volume divided by Young modulus. If it's for Poisson ratio to 1, then you use volume divided by Poisson ratio. So if you want to find Young modulus, you divide by Young modulus, your volume. Okay, if you want to find your Poisson ratio, or you use your volume divided by Poisson ratio. So it's easier for you to memorize. But what I just want to convey over here is, after I add them up together, alright, I have 0.0553. Alright, is 1 over E2 is equals to this. Alright, so when you want to switch, or you want to find E2, you're going to take 1 divided by 0.0553 is equals to E2. Alright, so please remember to change the fraction also. Alright, it's a very powerful careless mistake, always make. Alright, so once you get this, you should get about 18.06 GPa. Okay, so for your this thing over here, alright, 1 over Poisson to 1, alright, you can use this method to calculate. Otherwise, what you can do is you can use another formula, okay, where your V21, your Poisson ratio in the 2-1 direction, is equals to this one. Okay, so this one is another formula, it's quite important. Okay, and which is also this one. Okay, maybe I should plug it in, easier for you to see. So yeah, okay, so you can use two type of equations to solve for your Poisson ratio to 1. Okay, this is a more detailed way. So normally if they ask you to find your volume fraction of matrix of your fiber, then you need to work the backward. So once if happen that give you this value, and you're gonna work backwards to find these values. Sometimes, I don't know. Yeah. So in either way of things, alright, you should get your Poisson ratio to 1 as 0.0538. Okay? And your Poisson ratio, if you think about it, your Poisson ratio 1, 2, alright, you may wonder where is it coming from. It's coming from here. Okay? That is what we calculated. Okay, so maybe I should number it 1. So the first one we calculate, the second time, the third one we calculate, the fourth one we calculate. So the fourth one is the Poisson ratio to 1, and what we have is this thing. Okay, if you think about it, all these 4 things is the standard equations, alright, for finding your Q11, Q12, and Q22. Alright, all along it goes around is only Poisson ratio 1, 2, or 2, 1, E1, E2, that's all, nothing much, everything is the same. Okay, and the last one is your G12, so you need to find for your G12, which is this one. Okay, so what we have after you calculate, so I have the 5th step. Alright, after you calculate from this, your G12, you may encounter a problem because there is no shear modulus of your fiber and no shear modulus of your matrix. That is not given. So the next thing you should fall back, alright, the next thing you should fall back is, instead of that, you should use this general formula. Alright, but this is only for isotropic materials. What if you want a 1-2 direction? Then you're gonna just simply add in G12, E2, and Poisson ratio 1-2, and that's it. You wonder what if they ask us to find G21. Alright, in fact G21 is equals to G12. Alright, it's just shearing. So in matrix, shearing is the same. Okay, I may be wrong, but that's what I believe. So this is the equation for your G12. Alright, so once you have this is your Poisson ratio 1-2. Alright, we have this 2 already ma. So once you have this, we can calculate, and what we have for the answer is, you have for that is 6.854. Okay, and since our Q33, alright, is equals to your G12, then I can just simply sub in over here 6.854. Okay, next, last one is all this. I gotta find for my Q11, Q12, and Q22. Okay, and individually, if you were to calculate for all of them now, okay, calculation, alright, I found it is easier if I were to just find for this value first, since the denominator are all the same, so you can cut down your time. So what you can do is to calculate for this value. So V12 and V21, so we have V21 and V12. If I were to multiply this one and this one, what I have is 0.0171. So this 2 is 0.0171. So you can calculate this thing, the denominator already. Alright, so the denominator 1 minus V12, V21, alright, is equals to, good, so I have 0.9829. Okay, so finding all this is straightforward already, since I have all the denominator set. Okay, so once I find these things, so skip the step now. Okay, I'll straight away give you the answer for all this. Okay, you can also calculate. So I calculated all these values. You can verify yourself. Alright, but to keep them simple, normally you can just leave it as 108 or maybe 6 GPA or 18 GPA. Alright, for simplicity, if next time in the future, other than studies. Okay, anyway, so yeah, so this is how you get your Q1, etc. And then if you were to put it back into your matrix now, alright, so I'll just simply put in all these values, and that's it. Okay, so what I will have is this thing. Okay, and this is the answer for your QIJ. And what we have been doing so long, okay, is only one part of the larger part. Alright, where am I? Only doing for this one. Okay, and what exactly does this QIJ means is the stiffness matrix individually. Alright, for this one, for this one, for this one, and this one. Each of them has, I say wrongly, QIJ isn't for the angles yet. QIJ is simply for the matrix and the fibers. That's all. Finish. Alright, so in the next video for the QIJ transform, you're going to transform this thing. Alright, this is the your fibers and the matrix, but because there is certain transformation, alright, where you have certain angles. Alright, so in other words, each of them, for example this one, this one, this one, and this one, alright, 4 of them has the same stiffness matrix, QIJ. I repeat again, each of them has the same stiffness matrix, QIJ. In order to transform them from their own individual 1-2 direction, because this is 1-2 direction, this is another 1-2 direction, each of them have their own 1-2 direction, you have to convert them using a certain transformation matrix. Okay, and this is why you're going to transform each of the QIJ into the transform stiffness matrix, and this is why we need a certain transformation also. But again, in case it may blur you up, this QIJ is just the matrix and the fibers. That's all. Alright, so all this matrix, or all this lamina or all these plies has the same QIJ. Alright, because all their properties are the same. Alright, all the plies properties are the same, to keep it simple. Okay, so therefore in the next video we'll talk about transforming each of the ply into their own, based on their own angles. So once you shift them in terms of their angles, then the orientation will change the whole properties already. Alright, hopefully this is pretty clear, and therefore we have somewhat clear away the first part, QYJ. Alright, so next video hopefully we can clear away these three parts. See you then.